Okay, this video is going to be about electron configuration notation, and we're going to also explain how the diagonal rule is important to help us be able to do this kind of work. Okay, first of all, you have to understand what electron configuration notation, what does that mean? Okay, well, electron configuration, configuration just means arrangement, and notation just means writing. So we write down how the electrons are arranged in atoms, because the way they're arranged controls how the element reacts. And we love to know, why are fireworks sometimes green? Why does potassium explode when it touches water? It creates an explosive reaction, and things like that. Well, it's because the way the electrons are arranged that they behave that way. But before we can teach you why they behave that way, we have to understand how electrons are arranged. So, now, to make it easier to understand electron configuration notation, I'm going to use the diagonal rule to teach the way they're arranged. Now, it's not my favorite way. I prefer the block method, but this is a lot easier to teach online. So I'm going to teach this way with the video, and let's go with it and see what happens. If you have questions, please contact your teacher at any time. Okay, the Bohr atom model, remember, the Bohr model, the first, okay, here's the nucleus, let's just say it's a nucleus. The first energy level has 2 electrons, and I'm pairing them because in the first sublevel, that first sublevel holds 2 electrons. One electron spins this way, and the other electron spins that way. And they do kind of spread out, but for our model, I'm going to pair them because it helps these things be easier to count. It's how they're arranged. It's just easier to understand. Okay, the second energy level for the Bohr model, it holds a maximum of 8. Okay, we get the s electrons first, 1, 2. Okay, and p is the second sub-level that holds electrons for energy level 2, and actually it can hold 6. So I've got 1, 2, 3, 4, 5, 6, 7, 8 total electrons in the second energy level. But notice 2, 4, 6 came from the p sublevel. How cool is that? Alright, just to make it easier to see, I'm going to switch colors. Okay, for the third level, it can hold 18. Now the third level, the first sublevel is s, and it can hold 2 electrons. Okay, p is the next sublevel, and it can hold 6. Okay, 1, 2, 3, 4, 5, 6. Okay, now if I stopped right now, this would be the element argon. After that, they kind of stopped following the rules, so I'm not going to even draw that anymore. But the third sublevel is D. Okay, and D always holds 10 electrons maximum. That's the maximum it can hold. That doesn't mean we need all of them. Just like I stopped drawing after I stopped at argon. It doesn't mean we need all of them. We only use what we need to draw our electron arrangements. Okay, so then the fourth level, now we know that the fourth level from our notes, it can hold 32. So if I do 2 plus 6 plus 10 plus 14, that's how we get 32. Notice S always holds 2, P always holds no more than 6, the maximum capacity for D is 10 electrons. Well, the maximum capacity for F is 14. That doesn't mean you need them, but that's how many it can hold if you are going to use them in an assignment. Okay, when you set up your diagonal rule, notice you've got to make these very, very straight. Okay, make them very straight columns, and then you draw the parallel lines. Okay, and I spent time in the notes making those slowly and so that you could copy it easily, I hope. And also lined paper helps it keep it neat. Notice I'm using an index card because it's easier to manage than a ruler. Go ahead and do that too. All right, we will not draw any atoms using Fs. Elements that are that big are so big that really chemistry folks do not bother writing out arrangements this way. We're more likely to talk about them in terms of nuclear chemistry, like atom bombs, or a nuclear reactor, or nuclear decay, which we'll talk about later. Anyhow, so up to here, this is how big our pictures will go. We will not go this big, but seeing them this way helps the rest of it make sense. Okay, so that's why we set it up. Now, let's draw our first element. Let's draw lithium. And I don't see my sheet for, oh, here it is right in front of me, silly. Okay, so we're going to draw lithium, and I'm going to move this up. Whoops. Okay, so we're going to draw lithium, and lithium, we have plenty of room right here to draw our lithium atom. Okay, so first, like I said, we're going to follow the arrows to do our work, and we're going to start with the 1s2 electrons. We're going to always start here, follow the arrows. Okay, so 1s, okay, for lithium, we want 3 electrons total. Okay, well, in order to get the 3 electrons we want total, we have to put 1s first, because you always follow the arrows. Okay, just like that. All right, and notice it's 1s2. Lithium needs 3 electrons, so you know we have to have both the first and second electron possible, which are in the 1s2 sublevel. 1s sublevel, there are 2 electrons. Okay, after 1s2, follow the arrow, go all the way to the end, come back to the beginning of the next arrow, and notice that brings us to the 2s2. Okay, the 2s sublevel. Now, if I put both electrons, the 2s2, well, that would give us 2 plus 2, and that's 4. That's too many. I only want 3 electrons. So I'm not going to write 2s2. Again, that'd be too many. I'm going to write 2s1, because 2 plus 1, okay, that gives us 3 total electrons, and that's all we want. So that's where you stop. That is lithium right here. 1s2, 2s1. And with lots of practice, you get really quick at reading these and being able to identify elements. But 2 plus 1, we just add up the subscripts, okay, add up the electrons drawn at each step, 2 plus 1, and that's how many total electrons you have. And then stop when you have the electrons you need. Okay, let's do another element that's a little bit more challenging than lithium. Okay, and here is phosphorus. Okay, phosphorus is just a little bit bigger than lithium, but not too much bigger, because we don't want it to be too difficult right at the beginning. Okay, and notice phosphorus from the information on the periodic table. Okay, here was lithium, and here is phosphorus, letter P. Now notice that the symbols have a capital letter, and sometimes a capital letter and a lowercase letter. Handwriting matters, because capitals and lowercases, they all have been assigned meanings. So don't change them just because that's what your handwriting looks like. It's very important that you keep handwriting the way it's written on the periodic table, or like here, they're all lowercase. Just take a moment longer to write it the way it needs to be. Okay? Now, 15, we want 15 electrons total, because since it has atomic number 15, we need 15 electrons. Okay, so notice we always start back at the beginning. Okay, and the beginning is 1s2. So the first thing we write is 1s. Well, I want 15 electrons, not just 2, so I need all 2 of those. Okay, so now I have 2 electrons total. But of course we're not done. I need 13 more electrons, because 15 take away 2, I have 13 left. Nowhere close to done. All right, so at the end of this arrow, okay, you follow it to the end, go back to the beginning, and the next arrow makes you see 2s comes next. And again, 2 plus 2, now that gives me 4. And you can use a calculator to keep track of how many you've drawn. Well, I'm going to need both of those electrons, because right here 2 plus 2, that's only 4, and you know that's not enough. We want 15. Okay, let's keep going. Go to the end of that arrow, go up to the top of the next arrow. Notice the pattern of how we use the arrows. We go up to the top of the next one afterwards. So 2p comes next. So I write 2p, and then I have to decide how many I want. 2 plus 2 is 4. Now, this has 6. If I add 6, that gives me 10. And once again, 10 is not enough. We want 15. So I'm going to need 5 more. So I'm just going to go ahead and put all 6, and I still need 5 more. Okay, follow the arrow. Notice this time we have farther to travel down the arrow, and that leads me to 3s next. Here's 3s. Okay, now how many electrons do I need there? Remember, 2 plus 2 plus 6, that gives me 10 electrons right now. I need 5 more. Well, this only has 2, so I need both of those electrons. Okay, that takes us to the end of that arrow. Let's go to the top of the next one, and notice that puts me at 3p6 now. Okay, 3p. We can write 3p. We know we have to have them. Okay, and I have 2 plus 2 plus 6 plus 2, that's 12. If I stopped right now, that would be magnesium. I need some more. I need 3 more electrons. So I do not write 6. I don't need 6. I write 3 because that's all I need. And so again, if I do 2 plus 2 plus 6 plus 2 plus 3, that gives me 15 when I add those together. Okay? So 2 plus 2 plus 6 plus 2 plus 3 equals 15 there. Okay, that's how you do it. Okay, let's do another element. Okay, this element is going to be a lot bigger. Okay, so use 2 index cards to cover how much we're going to write. Okay, and again, this element is going to be bigger, and I'm going to take it down to here at least. There we go. Get that one. We're going to do palladium. Okay. Now, if I had my white gold rings on right now, palladium is one of the elements that help make white gold. Okay. Kind of cool. All right. So palladium has 46 electrons. We want 46 electrons. So we have a long way to go before we'll be finished. And just to show you, palladium is located very close to silver and gold. Here's palladium right here on the periodic table. It's right beside silver. Silver, Ag, when you age, your hair goes silvery. Gold, Au, aw, it's gold. It really means aurum. In Latin, aurum means gold, but aw, it's gold. All right, so let's do palladium here. You know we're going to start with 1s2, because we always do, and that's okay. All right. After 1s2, let's follow the pattern. Okay, we come up here, we're going to do 2s2. Okay, so right now I have 2 plus 2. Let me go ahead and write it down. That gives me 4 if I quit right now. We're not quitting. We need 46 electrons after all. So I follow the arrows. Okay, I'm at the end. I'll go back up to the top. That takes me to the 2p. So I write 2p, and as you can see, I want all 6 because even after I add 6, that only gives me 10, and I want 46 electrons. So we are not done. So let's continue forwards. We have 3s2. Okay, so I'm going to write 3s, and you know we want both of those electrons because even if I add 2, that only gives me 12 electrons like magnesium has. Okay, so let's keep going. After there, we go back up to the top of the next arrow, and that takes us to 3p6. So we write 3p, and if we add 6, it's still not enough, so we definitely write the 6 to show I want all 6 electrons that are in the 3p sublevel. Okay, let's keep going. Next is 4s2. 4s, okay, and 4s2, if we quit there, that would give us 20. That's still not enough. So I write plus 2. Okay, and after 4s2, we're going to have to go to the top of the next arrow. Okay, and we go up to the top of the next arrow. That gives us 3d10. Okay, and at 3d10, notice it is 3d. I realize this says 4s, but look at the arrows. See, 4s. Now we go to 3d. Don't rearrange it. Write it just like that. 3d. And yes, we want all 10. So I write plus 10 as I keep track of the math. Okay, let's keep going. If I had 3d10, that only gives me 30. That's still not enough. We need 16 more. So plus, okay, after 3d10 is 4p. So I'm going to write 4p, and I do write the 6 because that only gives me 36 right now. And if we stopped here, that would be krypton at 36 electrons. Okay, that's still not enough. Okay, so I'm going to tilt this out of the way for a second. Okay, after 4p, okay, we're going to go to 5s. Okay, and 5s, there's 2 electrons there. Okay, remember we said we had 36 so far, so I definitely want the 5s2 electrons. I want those 2, and I'm getting closer. Right now, if I added it up on my calculator, we have 38 electrons. We need 8 more, okay? We need 8 more electrons. All right, so let's look at what comes after 5s. Okay, here's 5s. We go up to the top of the next arrow, which is where 4d10 is located. Oh, but wait, didn't we just say we only needed 8 more? So do I write 10, 4d10, or do I write 8, 4d8? Okay, we write 4d8 because, again, all we want are 46 electrons, and if we wrote 4d10, it would be too many. So plus 8 more, put it in a calculator, you'll get 46 total electrons, and that is palladium. Okay, so remember to write only what you need. We are not going to rearrange any of this. Add them up, add up the superscripts. Okay, the superscripts tell you how many electrons we've got. Okay, here's 3d10, there it is. Okay, add up the superscripts, and here's that 8, here's where that 8 came from. Add up the superscripts and stop when you have what you need. Or write only what's remaining if you get to a point where it'll give you too many if you put everything it could hold. Okay? Do not rearrange any of the numbers like some people do on the internet. We are doing the order of filling. This is the order that they fell into the atom, if you want to say, the order they built the atom. And this is how we're going to do it this school year. Okay, again, contact your teacher if you need more help. Replay and pause this video as often as you need to until you see how to follow the diagonal rule. Okay, and I think you see this diagonal rule is pretty easy to set up as long as you keep it nice and neat and in very nice straight rolls. And you can use a ruler or an index card to help you draw nice, neat parallel arrows as you set up your diagonal rule. Okay, good luck.